how have you throughout your career, approached leveling up and upskilling as a developer? Has there been anything that's worked well for you?
When I started off as a software engineer, I always try to go deep into whatever I'm writing and try to understand what exactly is going on. I don't like to just copy paste the code from Stack Overflow and just put it and it works. But I don't know, how it works. So that's not how, I do things, and it kind of helps me if I try to understand the code which I'm writing. It helps me getting more control over it. If there is a change of requirement, like in the future, I can, do the code changes because I understand my code. I have to understand each and every line. So, I believe when you're writing, these programs, you have to clear your basics first.
Hello and welcome to another episode of Devs Do Something. Today's guest is Sachin from Biconomy. This episode was dedicated to the details of account abstraction and new technologies that aim to improve the overall user experience in Web3. In particular, we went into great detail on ERC 4337 versus EIP 3074 and talked through what infrastructure is required to actually get ERC 4337 implemented. This was a cool conversation because Sachin and Biconomy are working very aggressively on this, and it was cool to get some direct first-hand perspective. So we also dove into some of the second-order effects of ERC 4337 as well, such as how the user operation pool will work and whether or not this will open up other forms of front-running in addition to your traditional MEV. So if you're a dev that wants to be on the forefront of new developments in account abstraction, then this episode is for you. So let us know what you think, and I hope you enjoy. As devs, we all love hackathons. They're a great way to boost your skill set, meet other engineers, and add to your portfolio of work. At Superfluid, we've sponsored many hackathons and decided to start putting on a hackathon of our own, the Superfluid Wave Pool. This hackathon is a little bit different though in that it's continuous. It's always open. You can submit any project built on Superfluid at any point throughout the month and have a chance to earn thousands of dollars in prizes depending on how your project stacks up. In just the last couple of months, we've seen dozens of teams build really amazing projects that run the gamut from Superfluid developer tutorials to full-fledged applications to a proof of concept Superfluid StarkNet implementation that we thought was really, really impressive. So we encourage you to check it out today. You can learn more by going to superfluid.finance/wavepool. That's superfluid.finance/wavepool. Happy hacking. All right, we're here today with Sachin from Biconomy. Welcome.
Yeah, thanks, Sam. It's really great to be here. I've not seen these dev-related podcasts, very much lately, and I'm so glad there is one now. I've gone through, some of the podcasts, after you, send me the message, and they are pretty, useful for a developer, who likes to know, new stuff, what's happening, in the space from a developer point of view. I think it's pretty interesting, podcast we have done so far. I'm gonna listen to more over the weekend. But yeah, it's good to be here.
Good to hear. That's the goal. And hopefully this one is useful as well. So the first question we ask everybody who comes on the show before we get into all the fun technical dev stuff is how they got into crypto. So how did you get involved in this industry?
Okay. So it's been over 5 years for me in the space. So it all started in 2017 actually. I was, working in a Web2 company, and, my friend reached out to me. He was not Web3 friend, but he wanted to do some sort of startup in Web2 space with me. I have actually tried 2 times before, Biconomy. I tried doing startup before in Web2 space. Both of them didn't work. So always had this, in me, that I wanted to do something, on my own. So this friend reached out to me, that let's do something in edtech, industry. And at the same time, I have heard about, this blockchain thing that, was, people were talking about it. So, Sandeep from Polygon, like he's a co-founder of Polygon. He actually told me, like, he was actually building he was starting to build Matic at that time. So he told me that, this is, pretty interesting technology. You should look into it. So that's why, I started looking into blockchain, and started with the Bitcoin white paper, like everyone else does, right? So like Ethereum white paper, but uh, like I was not coming from a trading mindset, like, that I'll buy Ethereum or Bitcoin. It was not like that. Like, I haven't done trading in the past as well. But mainly, the technology like got me interested into it after reading, the Ethereum white paper. Like, there were some things, that got me excited, like how do you remove, the middleman and give the power, to the users? How can a system run without a central entity, running it? How all of this is possible. So these things, really got me excited, and I started like reading more about how can I actually, as a developer, be a part of this, blockchain, ecosystem. And then I figured out that you can actually build application on top of blockchains, and that lands me on Solidity language. So I, started learning Solidity. Uh, Tried, building, few application on my own, and it took me, around 6 to 7 months, to figure out that, oh, this is something I have to do. This is really exciting, and this is very like new technology, some, paradigm shifting technology. It had a lot of opportunities. It's very news based, so why not, try it out? And I told my, a friend who, who was asking me to do a startup. Okay, I'm going in the Web3 space. Web2 space is not for me now. And like in earlier, startups which I told you about, I the main reason, it didn't work because I was like I was in two boats at the same time. I was trying to do this, on the side and doing my job. So by that time, like after two failed, attempts in startups, I had realized that you cannot do two things at the same time. So in 2018, that was a time like I had realized this is something, where I want to go. I quit my job, in my earlier, Web2 company, and yeah, started doing freelancing, in the space, just to get my hands on, to more projects, to just to, get to know how actual applications are being developed on blockchains. That got me a freelancing job in a company called Stack City that was like based out of China that time. So I built, smart contracts for them. uh, that got me, increased my knowledge of Solidity, and some JavaScript libraries like Web3.js was the one, that was being used to query, blockchain nodes or connect to blockchain to transactions. So that's how, my journey, got started in blockchain space. And I did one project, and got to know more people. Web3 is all about community, and getting to know more people. It's still a very small, community, but that was something new for me. Being a part of community, coming from a Web2 space, and getting more and more people. They tell you about more opportunities. You get then connected to more and more people and more projects. So that helped me, getting more freelancing projects that time. And then that network connections got me, like meet my other co-founders as well. So we met, and then we got an idea, like let's do something together. I mean, they were not from a technical background. I was mainly, from the technical side. They have been coming, with a business background. For me, like it was a good combination. Like they bring something on the table which I don't, and I bring something which they don't. So we started doing some things together. And like before Biconomy, we were running nodes on Tezos blockchain. So like I knew like how to run a node. Like I just go to documentation, read how to run a node. We run a node. Like my Ahmed and Aniket had few Tezos tokens to stake. So that's why we decided Tezos blockchain, because we had tokens, Tezos tokens. So we were running the node, we were baking blocks. So in Tezos you don't say mining blocks, you say they were baking blocks. And we had this plan that we will get more delegations, and then we'll bake blocks, get rewards. But things didn't go that way. No delegations came. uh, then 3-4 months, we realized there was no ROI for running just a node and just taking few tokens. But that helped us in understanding the problems in the space. So like we knew like blockchains are there, anyone can run a blockchain node, uh, provide more decentralization, like provide security to the blockchain. But there were like many empty blocks there. No, like why there are no like so many transactions on these blockchains. Like, and then we realized it was hard to use these applications to actually make the transactions in the first place. So that got us think about the UX problem in the space. So I mean, that like we realized that this actually is a big problem to solve. Not many solutions are there that anyone can use in the space. So few of the applications were actually solving this problem in house. And it took a lot of resources and time to build these UX based solutions. So that got us an idea, why not like we do it, so other people don't have to do this. Let's build an infrastructure, these layers. So that's how we got started. And at that time, like in like early 2019, meta transaction was a thing, like in the developer community. I saw that you did a podcast with Austin Griffith as well. So he was, the guy who was experimenting around with new stuff, and meta transaction was new, at that time. So I had seen his videos about how like you can do a meta transaction, what meta transaction brings, and that's how I connected the dots. We have got a problem, we have got a solution as well. Let's bring them together, make it as a solution that's easy to use for other developers, so they don't have to build it on their own. That's how it all got started, and we are still like here building Biconomy.
I love it. Yeah, Austin was our second guest, so that's full circle.
Yeah.
But yeah, okay. So that's fascinating, right? You had the full kind of journey that a lot of us have, right? You went it's the almost ad tech to crypto pipeline, which is kind of funny. Now I want to shift into some of the things you're working on and really thinking about at Biconomy around improving UX. And I think the way to do it here at first is probably going to be to go into account abstraction. So this whole connection we made actually got started as a result of a lot of research we did for a previous episode with Julian Nisset of Argent, where we went really, really deep into smart contract wallets and account abstraction with him. But you put out a really, really good thread on ERC 4337 and what is the other one? 3074. Yeah, so you went through both of these things. The thread was excellent. We reached out and we're like, we should go deeper with you on this and a bunch of other things you're doing at Biconomy. But can you start off by just breaking down for us, a bit like you did maybe in that thread, the difference between these two approaches to account abstraction?
Yeah. So both are account abstraction solutions. Uh, One is like 3074 is the solution that requires protocol level changes. Like you have to change the protocol in order for the solution to work. Versus 4337, that's purely based on smart contract based solutions. There is no need to change the consensus of the protocol. and there's no need to include any new opcodes. So that's the very primary difference between the two EIPs. Uh, while both try to solve for the same things. Sponsored transactions. So anyone is able to pay gas fees on your behalf, and atomic multiple atomic operations done in a single transactions. So if we like go further deep into it, uh, 3074 is introducing two opcodes. One is auth, and then is auth call. Both opcode have to be first auth opcode. What it does is, uh, when you do a transaction and a auth is being called, there is a concept of authorized. There's a in the context of the transaction, you set a parameter called authorized using this auth opcode. So what it does is, when we send a transaction from an externally owned account, and how does a smart contract identify that who sent the transaction? It's a message dot sender property on this in Solidity. Using that, you identify that, okay, this account sent the transaction. Now in authorized, whatever like what this EIP does is, whatever address you set in the authorized field in the context of the transaction, that will be used as a message of sender for further interaction in the transaction flow. So there's one smart contract that's called invoker contract, that does use these opcodes, auth and auth call. So once auth is called, it has to have a signature from the end user, like from an EOA, and then that sets the parameter that this is going to be the message dot sender in the context of current transactions. Like, it's not a global parameter that you set on a smart contract, but it just stays there in the context of the current transaction. And then you do auth call. So what auth call does is, it uses that authorized variable to be used as message dot sender, and it has a signature as well. So you verify the signature, and you cross check whether it was signed by the authorized address that was set in the context. And once the signature matches, there are other stuff you can do in that invoker contract, uh, like paying for the gas fees. So it can act as a gas tank also. And then you just forward the call to any other smart contract you actually wish to call in that transaction. And that transaction will see message dot sender as the original user who actually who signed the initial message, not the invoker contract. That's usually is the case in the current state of EVM. So that's how 3074 tries to solve for account abstraction. uh, and this invoker contract, if you make parallels, this invoker contract is acting as a smart contract wallet for you. It is acting as a gas tank as well, and it's the entry point for your interaction of your transaction. So whatever layers are running, they will interact with this invoker contract first, and then any interaction will start in the transaction. So the concepts of smart contract wallet, paymasters, it's still the same in this EIP, but they're not different. Like, it's just one invoker contract that has all these signature verification logic and gas payment to the layer. That's how 3074 tries to solve. It has some limitations in terms of native value transfer. So since transaction is going via this invoker contract, but you have funds in your EOA account. So when it comes to sending the native currency in your EOA, uh, what this invoker contract is supposed to do, that whenever you send a value, uh, and when it passes message dot setter as your address, but there's another field called message dot value, right? If in a pure account abstraction you want to do this, you have to overwrite both values, message dot sender and message dot value. But it does not like override message dot value right now. As per the EIB, it is expecting that you have funds in the invoker contract in case of native, value transfer. So that kind of makes it difficult, to do a transaction where a native currency transfer is involved. So this particular, scenario, this EIP does not solve right now. Uh, and there are reasons like why it cannot uh, transfer the native currency in between the transaction execution, just like how it did, change message.sender. It could just, get the transfer the value from the account. But this affects the validator logic, when, validator is handling transaction in the mempool. It's also like before actually sending the transaction, it's also checking what balance, you have, whether you have enough balance to pay, for the transaction. So changing the account native balance in between the transaction execution kind of like affects, those scenarios. So that's why it's not like straightforward to just deduct it from the EOA and then pass it on to the next contract. Now, this was 3074. Now if you go to 4337, it introduces the concept of smart contract wallet. So instead of EOA, your identity is a smart contract wallet. Even though it needs a controller account as an EOA, but it does not have anything to do when you are talking about funds. It's just there to authorize you know transactions using signatures, and then signature verification happens on smart contract wallets. So in 4337 there are other smart contract as well. One is entry point, just like how we have invoker as the first entry point of the transaction. We have like its name is itself is entry point. So you have an entry point contract. Any meta transaction that relayers or bundlers wants to initiate, they have to talk to entry point contract and send the transaction first to it. And then there's a concept of paymasters in 4337. So paymasters are like your gas tank, where you load the gas, and that gas will be used to sponsor this transaction. So how, and you have a smart contract wallet. So there are three entities on chain, and all of them are interacted with while doing a gas-less transaction or a sponsored transactions. Now, how does that the smart contract works? Paymaster, it's a gas tank, so you put gas over there. But actually, the gas stays in entry point contract. So when you deposit a gas via paymasters, paymasters are connected to entry point contract. So there is an accounting in the entry point contract that this is the paymaster address. It has deposited, let's say, 4 ether of gas. So entry point is doing all the gas accounting for the paymasters. And so when transaction comes, this 4337 type transaction comes. So just how you define a raw transaction, it has to from data, nulls, gas price, these parameters. In 4337, it's called a user operation, like a user op. So when you send a transaction to a entry point contract, it expects you to send a user op, or in to be exactly an array of user ops. Like you can bundle multiple user ops and send in a same transaction. So there's a method in the entry point contract called handle ops. Relayers that slash bundlers call this method on the entry point, and then it does certain validations of the transactions. So first it checks whether paymaster address is there or not. Who is going to pay for this fees. So there's a paymaster fee, paymaster and data. It has the paymaster address in it, and some data appended to it, which I'll come to later. So it first check whether okay, this is going to be sponsored by paymaster. Now we also have the smart contract wallet. If it is your first interaction and your smart contract wallet is not deployed on chain, it checks that. So in user op, there is also an init code which you can send that will actually deploy the smart contract wallet first. That's the first step, and entry point does. Once you have smart contract wallet deployed, now it, as per the EIP, if you want to make your smart contract wallet compatible with the EIP, there is a function called validate user op. You just have to implement, that interface. And the entry point contract calls the validate user op, it send the whole user of object to the smart contract wallet, and their signature verification happens. So when you initiated the transaction, there was an EOA. So when you click, let's say, send, or you start initiate a transaction, the EOA has to sign that user op. Now that signature verification happens in smart contract wallet in the validate user op method. So once entry point communicates with the smart contract wallet, and it says, okay, signature is valid. My controller has actually signed this message. It looks fine. It sent the message back to entry point, and then entry point do the same check with paymaster that this is a user op. Someone would like to get it sponsored. Do you validate this user operation? Are you willing to pay for this user operation? Then verification happens on paymasters. uh, like paymaster has again this validate user method, where it can have any arbitrary validation logic. Some paymasters do it on chain, some paymaster do it off chain. So those paymaster that does it off chain, we are calling them verifying paymasters. So like it's very simple. You have a account on paymasters, and then you have verification logic actually off chain. So I remember, you remember I told you paymaster and data field is also in the user op. So paymaster address and some paymaster data. So this is the data which paymaster verifying paymaster is actually verifying. And all the verifications they are doing like off chain, like before initiating a transaction, maybe you communicate with a signing service and verification and signing service that this is my user op, are you willing to pay? Now off chain system checks all the conditions, whether it's a smart contract, what interaction it is. Like any arbitrary validation can happen off chain, and this service can actually sign a message which you append in the paymaster and data, which is being sent to the paymaster validation method, and it's just checking whether my off chain signing service have signed this or not. If the signature matches, that means the paymaster can be ensured that the verification was done off chain. So that's how verifying paymaster works. But the whole idea is paymasters have also to verify whether they are willing to pay for this transaction or not. Once that happens, you have got all the validations, then you just execute the transaction via the smart contract wallet. And once transaction go via smart contract wallet, it's up to the smart contract wallet how to handle that method. You can literally name it anything, execute, or execute transactions, anything. And then it's rest is just plain interaction with other smart contract wallet, where you call smart contract wallet B from A. So for B, A will be the message dot sent. So since smart contract wallet is already your identity, all your funds are there. So it's easy, to plug in literally any smart contract wallet. You don't have to literally plug in any smart contract. You don't have to change anything or to make it meta transaction compatible. There's no such thing, in this flow. Any contract like written 4 years ago, like can still be used, in this sponsored transactions. And once you have executed the transaction, it comes back to entry point. It do all the gas calculation, how much gas has been used so far, what is the final gas fees, that it has to refund back to the relayer or bundler. So after final execution, since entry point already has the funds from the paymaster, so it can do anything with that fund, and it already know what paymaster was used in the user op, and it has validated that it is willing to pay for it. So what entry point does is it takes those funds from the paymaster deposits, it send it back to the relay, and the whole execution finishes. Relay has got the fund back. Usually whatever relay pays, it should get a bit more as a refund. That's relayer's incentive to send these transactions on chain. And you are trusting entry point contract that it will do all the verification with the paymaster, with the smart contract, and will do the gas calculation correctly, and it will send back the gas back to the relayer. So that's the kind of trust you are putting in entry point contract. So that's how 4337 does an account abstraction transaction. uh, yeah, that's that this is the transaction flow difference, between the two.
I love it.
I hope
I
it
love
was
it.
not long.
No, this is good.
Yeah.
This is good. We got the full deep dive. And you know what's good about this is that okay, while you were talking, I pulled up the and I'll link this in our show notes for those of you listening. I pulled up the like the diagram that goes with 4337 where you have like all the users and they submit to this
Yeah.
nice cloud that's the user operation mempool. They go into a bundler and then they're bundled into transactions and then they go into a block, right? Like that's what you see. It sounds like, and please
Yeah.
correct me if I'm wrong and my misunderstanding is incorrect about this. It sounds like there are some other things required to actually implement this, right? There are smart contract wallets, I guess I'll ask a follow up question on smart contract wallets in a second. But you have smart contract wallets, and you have this paymaster that allows people to effectively use like the gasless transactions thing that people like alongside
Yeah.
4337, right? Which I think is really interesting. So are these like new developments on top of like are these like implementation details on top of like the original spec? Like how was the discussion evolved here?
So this 4337 who the guys who came up with this EIP, they're the guys who came up with the gas station network, GSN. And this paymaster concept was still there when they tried to come up with the way of doing cashless transactions. So it's not a totally new concept that just got introduced in the CIP. It was like way before that, when GSN built this protocol for doing cashless transactions. And since there was not much adoption of GSN because of various reasons, it was maybe a bit hard to do, or whatever the reasons was. But uh, this e- this GSN actually evolves to this new EIP, and Vitalik himself contributed to this EIP. So that's how it came, the concept of 4337. Yeah, so it's not like a new thing. It has been worked before, but in some other form.
Sure. So I think there are a lot of teams now that 4337 has been kind of given a sort of stamp of legitimacy. And it also sidesteps this whole thing where, people don't have to go to the all devs call and champion for these new opcodes. They don't have to get into that war zone. They can just implement this and try to convince other app developers to implement these solutions as well. So, I mean, there are lots of teams building some infrastructure around this. You guys are at the forefront of it. How do you see this? I mean, I think you have your own bundler implementation that you spec'd out, right? Is that live or is that still a proof of concept stage?
So this, as per this EIP, so whatever I have explained was all the on-chain parts. Now there is also an off-chain part, like this bundler is an off-chain entity that is actually sending these transactions. Uh, Now, one way is you just create a single, bundler, get your DApp, just communicate with the bundler. You send the transaction to bundler, it relays the transaction. That's like very simple way of doing things. But you cannot just rely on single bundler, implementation. That's why this EIP also mentions how a bundler should be created. It should be like a P2P network of bundler, not just single bundler, communicating with the app. So there is a concept of P2P communication between the bundlers. There is a concept of user of mempool. Now this mempool is the pool of transaction, or I would say user of a pool of user operations that sits in these bundlers of chain. And these bundlers then try to make a bundle of user op. So imagine like multiple applications trying to send multiple user op to this network of bundlers, and then you end up with multiple user operation in the mempool. Now, as the name suggests, these bundlers should be bundling things, right? Now they are bundling these user operations. So it's not that they are just sending one user operation, picking up and sending. So they are bundling them in the order of like maximum profit. So whatever bundle gives relayers or bundlers maximum profit, they will try to pick those user operation from the mempool. So, and then they will make a bundle, send it to on chain. They will pay the base fee, which is 21,000, but they will get all the premium, from all these user ops. And at the end of the transaction, at the end of bundle execution, you bundler is supposed to get like more native currency back than what it paid for, and that's the profit for the bundlers. So there's a whole specification on how you should create a bundler, how these bundlers communicate with each other, what is the format of that message that is being communicated. I mean, these things are not yet spec'd out properly. There's a discussion ongoing. There's a Telegram channel called 4337 bundlers where this discussion is happening. And initially, the team which came out with 4337, they have published, the guys from Infinitism and Nithamite. So they actually built this initial bundle implementation, and they also published a test suite, which you can run against your bundle implementation and verifies that it is compatible, with this EIP, and it is how it should work, in the network of bundlers. So those part, the bundler side of things, specifications are still being finalized. Whatever bundlers you see today running, they are just single node or single server accepting transaction directly from the node, from the client, or dApp, and that's just sending these user operation, uh, one user operation to the entry point contract. But this is how the whole bundler networks are going to evolve, and it's gonna be a network with user of mempool, and then each bundler will uh, you know compete with other bundlers that I have built the bundle which will give me maximum profit, and I'm going to execute it first, like before you. So that's how as per the EIP, the whole thing's gonna grow.
Yes.
And
Okay.
there are other concerns, like it's I can just go on about this, but when you compete, uh, so there is a concept of front running these transactions. So
Yes. Yes. I was gonna bring this up, right? The first thing my brain went to when I was like reading about 4337, and I was like, all right, we have like basically a parallel mempool here.
Mm.
MEV, user op MEV is next, right? Is that where you're going
right,
with this?
exactly. So see, these bundlers, they are there for the profit, right? They want to like make some revenue out of it. One piece of revenue is the premium which you get from by executing the user op. Uh, so in this user op, there's a, just like in 1559 gas structure, you have this priority fee, like a max priority fee and the max fee. Similarly, user op also has these fees, like max fee and max priority fee per gas, uh, which tells the entry point contract that this is the maximum fee this transaction will pay back to the bundler. And if the actual execution goes beyond the user op, the transaction would fail on chain. So entry point will ensure that whatever is there in the user op, like at least that is given to the relay. And max priority fee, like since all bundlers are prioritizing the user ops in the mempool based on this field, so as a user or a dApp, if you want your transaction to be included first, again it's a war of sending a higher max priority fee in your user op just to get it included first. So this is like one source of revenue for the bundlers. And then, as you mentioned, these bundlers could find out MEB opportunities associated with that transaction, and they could just bundle their own transaction along with those user ops and just grab that MEB. So this is a race for sending the transaction, sending the bundles, and getting more profit out of it. Now the part where front running is coming here. Now imagine bundler has built a bundle and put some MEV transactions into it and then send it to on chain. So when you send the transaction, you call handle ops method of the encrypted. It has two parameters. One is beneficiary, the whole refund, like which address should get that refund. That beneficiary address is okay. It does not go to transaction.sender or transaction.origin. It goes to that beneficiary address, whatever bundler mention it in the transaction. And then second parameter is array of user operations. So just a very simple method, handle ops. Beneficiary is there, array of user op are there. Now, if I, as a front runner, see this transaction, like in public mempool, of the actual validator nodes, I can just pick the array of user op, build another transaction, put my beneficiary into it, and front run it. So I will get all the premium, from by running those user ops, and your transaction would fail. Uh, because it will change, some states and nonces, in smart contract wallet, and it will fail in the verification part. That's the biggest, concern, uh, with this EIP. Uh, and it's not just the front running. Now imagine, I am the user. I have this smart contract wallet, uh, or I'm the paymaster. Like I have put some funds in the cash sent. Now I have sent the transaction via this bundler network. These bundlers have sent my transaction on chain. It's lying in the public mempool again. Now I, as a paymaster, goes on chain and do a transaction that remove all the gas from my paymaster. Now when it executes, it will fail, and the bundler ends up paying for those failed transactions. And similar thing a user can also do. User can just change the state in a smart contract wallet, and you know uh, it will end up in failed transaction. So how can you avoid all these state changes that are happening before the bundle is being executed? So uh, like one way to avoid this is to use private RPC uh, endpoints, which block builders will provide. Like right now, only Flashbot has this private transactions where you can submit your transactions, which does not end up in public mempool on the blockchain. So if you have this communication with the block builder and you send this bundle to that block builder, and you tell them, this is a private transaction, do not put this in the public mempool so others cannot see it, and when you include it in your next block, just keep it as the first transaction in the block. So you are ensured that no state will change when your bundle is executing, uh, and versus like when you estimate it, that bundle will actually succeed. So there is no state transaction in between, and that's how you can actually avoid these front running problems, and other problems where you are actually griefing the bundlers and forcing them to send failed transactions, basically, right? So that's the solution. But I mean, right now there is no such private RPC solution from these block builders that these bundler network can use. So right now you have to come up maybe with another solution that will prevent these front running attacks or griefing attacks, which is kind of hard to figure out. A solution without these private RPC endpoints. This is something like we are also trying to figure out. I mean, there is one solution that prevents front running, but it does not prevent griefing attacks, where paymaster can actually, change the state before your bundle get executed. Now, in this case, you cannot prevent this, but what bundlers can do is identify, why your transactions are getting failed. Is it because paymaster state was changed? in between when you simulated the transaction versus and when the actual execution happened on chain. Now if you see these paymaster doing these fishy stuff, or they are intentionally trying to grief you, the best you can do is like block them. So any further user operation that comes with that paymaster, the bundler will not like accept those, because it is not acting properly in the network. So this is how you can actually avoid long term griefing. uh, yeah, these are like current solutions to these problems. Yeah.
Interesting. So yeah, I think what's underappreciated about this is that there's complications here. Like this is going to improve UX, but it's not going to come without problems. Many of the problems might just be hidden these hidden battles between, bundlers and people front running each other. So yeah, there's no
Yeah.
free lunch here. And I guess one question I had to follow up is like how long is this anticipated? Like I think that the issue here is that there's a delay, right? So like I submit my user operation. All right, those are bundled, then
Well,
they're submitted to like whatever chain I'm going to be executing this on. Between that
mm,
bundler coming up with their, I guess, bundled kind of block, but bundled set of transactions and submitting it to the actual mainnet, there's a there's a delay. I mean, how long is are there like expected guidelines on how long the delay should be in some of these bundler specs, or what's the thinking there?
yeah, I mean, there is no limitation or guideline in the specification on how long it should be there. But it's in the benefit of bundlers to send these user op as soon as possible, because they are getting profited by sending them. So there's no as such specification or guidelines. But yes, there is going to be slight delay uh, when you send the transaction to bundler network, and then they pick it up and send to the transaction. But it won't be like that much comparable to the block confirmation type on the chain itself. So even though it might be like 1 second or few seconds, uh, but it should not like affect the user experience that much, which they are already like used to. You send a transaction, you wait for the confirmation, and then in order for like safe transaction, you wait for more confirmations, just to ensure that it is not like there's no fork happening on the blockchain, or no reverting happens. So as compared to that, like it's not gonna like add comparable delay.
Gotcha. Makes sense. Makes sense. Interesting. So this is going to be really interesting as this evolves. Another thing you guys put out, this might be separate, right? This might take us into slightly separate territory, but it's also around a similar concept. But you put out a blog post. I want to say this was earlier this year, around fixed price, or not this year, but late 2022, about around fixed
Yeah.
gas price transactions. Am I right that this was that recent?
Yeah. So we were trying to experiment around you know how can we do things differently that ends up in better user experience. And there have been these conversations around, if we if I can estimate uh, that on like I have $10, I want to get like surety that I can submit 5 transactions using $10 without relying on like price fluctuations or anything. Like it would be a pretty good user experience, right? You can set aside your some funds, and you are ensured that you can actually do 5 transactions anytime, on public, on any network. But it's not that simple to do. uh it all comes down to selling block space at certain fixed price. So there has to be a one-to-one like communication with these block builders, and there has to be a deal cut out with them, because they are the one in control of building the blocks and including your transactions. So maybe you incentivize them in other ways, which is not coming directly from the user. So you are like in a way uh, buying the block space and then giving it back to the user and you somehow try to hedge the gas that are being paid. So you take, let's say, $10 from user, but your sometimes you pay less to these block builders because you have cut out a deal with them, and in the long run you end up on the positive side. So you don't end up like losing money over time. It may happen uh, like when the gas price fluctuates, like there's a spike in gas price. Now it will depend like on the deal which you had done with the block builders. But this was not uh, worked on that extensively because of priorities, and we had other things to do. But this was an idea that originated, and it's not that the idea has gone into limbo and we are not like thinking about it. But once even this builders network are supposed to communicate directly with block builder via private RPC. So once these connections starts happening with the block builders, and we see this ecosystem where block builders are not just building blocks as per the validator code, but they can run more code apart from the protocol itself. Just like how it happened with flashpot, right? You manage to get more validator nodes to run your extra piece of code in the validator node. So as these kind of ecosystem will grow, and we'll have more accessibility to block builders, uh, then I think these kind of things are possible where you are selling block space and cutting out a deal with these block builders. But yeah, it's too early to implement that right now.
Makes sense. The I'll put a link to the post on this that you guys put out. I think it was fascinating because it, like you said, it'd be great to be able to treat block space like you treat any other commodity, right? Like big companies that need to buy a lot of oil, like airlines, they hedge against future fluctuations on oil prices, right? So it in reality it feels like it should work the same way when it comes to gas prices, but like you said, there's a lot more complications here, and hopefully we can all crack the code on this one. But okay, maybe we should move on then to some more specific things regarding like what you guys are working on, because we're running up on the hour here relatively quickly. So let's say that I'm just like an application developer, right? I'm interested in what you guys are doing. I've seen some noise around the Biconomy SDK and things like that, and I want to begins like supporting these kinds of new UX experiences in my DApp, right? I'm an application developer. How would I go about implementing these gasless transactions and smart accounts with Biconomy? Like what are the kinds of mental models I need to understand in order to take advantage of some of this stuff?
Yeah. So first of all, like you have to understand the the identity of the user, how you are showing the identity to the user on your application. uh, right now most of the dApp uh, like relay this identity management to wallets. So they just take the currently selected address and just show it on the dApp. But most of the stuff like balances, transaction history, that is shown in the wallet, and any user can access it. Now you have to change that mindset when you are building or account abstraction concept, because here EOA is not your identity. Your identity is smart contract wallet, and not many like existing wallets have adopted this account abstraction concept where they are showing the smart contract wallet as like the front identity to the user. But this change of mindset has to be there, like in the developers who wants to like build on account abstraction. Now this EOA which we are talking about, which we are trying to abstract away from the user, uh, why show that EOA at all to the user in the first place? Why tell the user that you have two accounts? One is EOA, one is smart contract wallet. This is your controller, and this is where your funds will be. And that's where the social login concept comes. Now, since the first step always has to be onboarding, So you always have to onboard the user first on your dApp, and then user interacts, with your application. So when you onboard a user, uh, you do not want them to download a wallet or you know set up a separate wallet. So what we are trying to do, in Biconomy SDK. So Biconomy SDK has solutions for onboarding. It has solution for engagement using these sponsored transaction, guest list transactions, and it has also solution for fiat on ramp. So for onboarding, we are like currently using Web3 auth, where you can just sign in with your email account. Uh, and then it's similar to Web2 signing, where you just put email password, you sign into it. Once sign in is done, what Web3 auth does is it creates an EOA uh, associated with your social identity, and then we don't need to show that EOA to the user. For user, you logged in via your Gmail account, and then associated with that EOA, there is a smart contract wallet. Now, the good thing about this smart contract wallet is it is counterfactual in nature. By that I mean, even though your contract is not deployed on chain, you can still know like what will be your address once it is deployed. So just by logging in using a social account, you can actually know this is going to be my smart contract wallet, even though I'm a completely new user. uh, and then you know uh, you show them some fiat on ramp solution just to get some funds in your wallet. uh, you tell them, okay, this is your address. Maybe you can deposit your funds from an exchange if you are a user who have some funds in exchanges, which is also like user friendly interface in these centralized exchanges. I'm not talking about DEX. And then uh, there are like crypto native users who understand this, that this is the address. I can just transfer any funds from any of my other accounts to this smart contract account. So this is the onboarding part. Like to a normal user, you just sign in with a social account and there is your account. Now next part is interaction. So you might be asking, like, if there's a smart contract wallet, it has to be deployed first before it can process any transaction on chain, right? So what Biconomy SDK does is, whenever you are initiating any transaction, it first check, like in each transaction, it checks whether the smart contract wallet has been deployed or not. If it is not deployed, it patches smart contract wallet deployment transaction. So, you know, uh, as I earlier explained, in account abstraction user operation, there is an init code field, and you can actually put the wallet deployment code, in that. So, you know, in the same transaction, your wallet can be deployed, and then you can actually interact, with your wallet. And then SDK has all the helper methods to help you build that user op. So you don't have to go and fill each field in the user op. You just have to tell that this is my smart contract I want to interact with, this is the address, this is the API, this is the method I want to call, these are the method parameters, like normal way of interacting with smart contracts, right? And then SDK internally will actually build that payload. uh, and And now, as a dApp developer, you also have to set up paymasters if you are sponsoring, transaction for your users. Now, in order to make it easy for the developers, we have built this dashboard, uh, paymaster dashboard, we are calling it. It's not live yet. It will be live by the end of this month. So on the dashboard, you can just go configure your, create a tab, uh, and then set up a paymaster, uh, deposit the gas. So, as per the EIP, every dApp should be having their own paymasters. So, they should be deploying their own paymaster. But what we have done is we have modified this concept and created a singleton paymaster. So, not every dApp has to deploy their own paymaster. So, there is a paymaster. We have deployed it. And then there's a concept called paymaster ID. Okay. So this paymaster manages the accounting for different paymaster ID, and you just deposit in this contract, and this will deposit into entry point. For entry point, it's just single paymaster, but this paymaster has like multiple sub accounts, you can say, or paymaster ID. So just to make it easy for the developers, they don't have to go through all this step of deploying paymaster and all those things. So on the dashboard, you can set up your funding ID, uh, and then you can deposit gas from the dashboard. So it's very simple, as a developer. Go to a dashboard, sign in, create a dApp, set up your funding ID, deposit gas, and there you go. Now, earlier I mentioned verifying paymasters, where you have to uh, verify whether you want to sponsor it or not. Now, as a dApp developer, of course, I would want to sponsor transactions that are interacting with my smart contract, my dApp smart contracts. So you can actually configure these smart contracts on the dashboard, and also, mention, okay, this is the method I want to configure. And then the off-chain signing and verification service, which I was talking about, we are also running that for developers, so they don't have to run it. Even though on the SDK there is a complete option of mentioning your own paymaster, mentioning your own off-chain verification and signing service. If you want to run, you can run yourself and just configure the SDK to communicate with that service instead of our service. But again, it's just to make it easy for the developers to onboard. So SDK communicates with this so when you configure the SDK, you give this dApp ID which you got from the dashboard. Using that dApp ID, off-chain signing service would know what conditions to validate against this user op, and then it will sign a you know it will produce a signature that will be verified on paymaster, which we have deployed already. So we have the key which will sign, and the signature will be validated against the key on the paymaster. So all this is happening. So SDK is interacting with this off-chain signing service. SDK is interacting with SDK backend node, which we have created just to uh, make certain things, just to offload certain calculations from the client side. So just backend server doing gas estimations, and providing APIs for getting token balances in your smart contract wallet. So these kind of things. So you can actually configure this SDK, whether to communicate with your own deployed SDK backend, your own deployed signing service. You can do it yourself as well, but we are doing it for the developers. So that's how this Biconomy SDK works. You can actually go to biconomy.io. There's a documentation section. Like there are like multiple examples of how you should do it in React.js, in Node.js, in React Native. So all different stack examples are there. So it's pretty like easy to follow over there. So, but yeah, that's how you can actually use the SDK, and you have to keep in mind the onboarding notion. It has to change from the EOA to a smart contract wallet, and then that's it. Like you click a transaction, you click a button to initiate a transaction. Now, since you are using Web3 auth for generating your EOA, you don't see a pop-up for signing the transaction. You just click, sign is taken from your EOA account, and sent. This SDK is behind the scene communicating with these services. It generates an user op, get it signed from your EOA behind the scene, and send it to the bundlers. And then as a user, you just click the button, and that's it. And your transaction actually went through on chain. You get back the response from bundler. SDK handles that response. It tracks the transaction hash on chain, and then it tells you that your transaction is confirmed now. And then as a dApp developer, you can refresh the state of your dApp.
Nice. Yeah. So we'll link to that, and I think it's going to be cool to see application developers start using this stuff. I think the biggest two things are really just understanding that you have to integrate smart contract wallets. That's kind of the first big thing, and then if you want to enable gasless transactions and things, you can make use of this paymaster contract that you guys deployed. I like the fact that you made the singleton, right? And they're just basically using that single contract to, do the accounting. I think that's probably cleaner just to just interact with that. But I like it. I like it. So two more questions that are maybe a little more just kind of like general in nature about you and like how you see this stuff evolving. Um, we like to ask everyone who comes on, especially people that have done technical work for a long time, like yourself. How have you throughout your career, approached leveling up and upskilling as a developer? Has there been anything that's worked well for you?
So, when I started off as a software engineer, uh, and even before, like when I was in college, I always try to go deep into the into whatever I'm writing and try to understand what exactly is going on. I don't like to just copy paste the code from Stack Overflow and just put it and it works. So but I don't know, how it works. So that's not how I do things, and it kind of helps me if I try to understand the code which I'm writing. It helps me getting more control over it. If there is a change of requirement like in the future, I can do the code changes because I understand my code, right? But when I say I understand my code, I have to understand each and every line of code, not just overall method that this method is doing this and it is returning me that and I'm good. So you have to understand like what's inside that method as well. So like I believe when you are doing when you're writing these programs, you have to clear your basics first. So I see these developers trying to directly build Solidity, smart contracts. Just copy this ERC20 contract, just deploy it, and then you are a smart contract developer. That's not how you become a smart contract developer. You have to first understand the basics of programming. You have to clear the basics of data structure and algorithms. You should know like what are the different sorting algorithms, what are different searching algorithms, which are very basic things you find in programming. Once you have these basic knowledge of these primary and basic concepts in programming, then you go ahead learn you know multiple languages, and then you try to implement the programs. Then you will feel like more confident as a programmer as well. So any challenge that comes your way, once your basics are clear, you can easily connect the dots and come up with a new algorithm that actually solve that challenge. And this I got this inspiration by watching these Star Doc videos by Neil deGrasse Tyson. He does this Star Talk, and I really love this guy. He knows all the basics of physics. He understand like what's happening at like atomic level, molecular level, and he will explain all these things to you in a very simple language, like why the night is dark. Like, it's not because it's nighttime. I mean, there is a separate reason for it. And then he will explain you on a very higher level, and can go down deep into the molecular level because his basics are clear. Once your basics are clear, you can actually explain any complex stuff in a very simple language to other other developers. So just taking an analogy over here. So the main thing is like get your basics done first instead of uh, running into complex programs, and then it will be easy for you to connect the dots between different ways of doing things. And then you will be like I think you will be a better programmer that way if you start your journey that.
I love it. I think that's really, really good advice. And I can second that. It is very tempting, especially when you have deadlines, to just like make the
Yeah.
thing work and figure it out later or not at all. But it's far better for you in your career to just deeply understand the explanations behind what is happening, right? So I think that's
Yeah.
fantastic advice. Okay, so final question. This is again even more general, but we love to get everybody's take. let's say we fast forward 10 years into the future and we look at like what the space looks like and what everybody's built. How do you hope
Mhm.
the industry evolves over the next decade?
Okay. Like, so right now, we are all about building that abstraction layer on top of this blockchain technology. So if you ask me, like, in 10 years how it will look like, I am expecting it to look like in a way where you are using the blockchain technology in your day-to-day lives, be it messaging, like sending messages to your friends. Behind the scene, blockchain technology is used, you don't even know it. You are doing payments, you are paying your phone bills, you're paying your electricity bills. uh, Under the hood, again, maybe, crypto is being adopted by, governments by that time. And this crypto payments becomes official, mode of payment. And then everyone, is adopting this blockchain technology, and it is in your day-to-day life. But since there's an abstraction layer on top of it, it becomes easy for application developers to build these payment solution, messaging, applications or social networks, without you knowing that blockchain is behind the scene. So this is how, I imagine, the world, like in maybe in 10 years. And every mobile device is somehow, a part of decentralized network. And the way we are progressing in technology, in processing, speed, and the way we are progressing towards segregating, like, different components uh, into each separate module that can run on a light client. We had the concept of light clients, like they are light in nature to run. And then, like, gradually, I think these blockchains will be divided into separate components, where each component can be run even on a mobile device. And you are, in some way, a part of a bigger, decentralized network, maybe doing validation of transactions, I don't know. uh, but in some way, you are, part of a bigger network. Every mobile device is running, this whole decentralized network. And that's how I imagine the world is going to look like.
Pro decentralization and pro abstracting
Yeah.
away the hard things, which makes a lot of sense given what you guys are working on. Uh, well, listen, hey, I really appreciate you coming on. This was a really interesting conversation for me. I actually learned a lot, and I think we got a really comprehensive view of both the EIPs and the ERCs that have been proposed, how they work at a deep level, how people are looking to implement them, and how you guys specifically are implementing them at Biconomy. So we really appreciate you coming on. And before we hop off, is there anything else you want to tell our audience as a final message?
uh just try out, our Biconomy SDK if you are, building on account abstraction. And on biconomy.io, just go to the documentation page. There are like a lot of examples over there. And we have a forum as well, like forum.biconomy.io. If you have any open questions, you can just post it there. We'd be happy to, engage, over there. uh, and that Yeah, that's the final message, like, I would do, like, give to the developers, and try to build uh, the application that makes sense, not just hero NFT applications. Sorry for that. But
Yes,
so yeah, just want to see like more diversifications in the applications that are being built.
I love it. I love it. Well, hey, thanks you again. This has been a lot of fun, and we hope you have a good rest of your evening.
Yeah, thanks, Sam, for having me on the show.